Hello, 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 hello. Once again, we are going to discuss now a simulation. This is a simulation of basic trigonometric functions that we have. So I am going to tour you in the different basic trigonometric functions. We're going to simulate it. So as you can see here, I have here the basic trigonometric functions that we are going to simulate: cosine, sine, and tangent. So we are going to specify the special angles, the labels, and also the grid. So this is a simulation. We can either choose in terms of radians or in terms of degrees for the angles. In this particular case, I chose degrees. So we are going to show the special angles, including the labels and also the grid lines. So we are going to simulate here 1 unit for for the trigonometric functions, 1 unit for each in the quadrant of the 4 quadrants that we have. So remember, you have the first quadrant has a positive x and y values. Second quadrant has a negative x value, positive y value. Third quadrant has negative values for both the x and the y. And the last quadrant, or the fourth quadrant, has positive x value but negative y value. So let us begin with, given x is 1 unit, and that means and y is equals to 0. So there will be no angle that is formed if that is the case. And so if you are going to take note of the cosine value, that will be x over 1, or that simply equals to 1. However, if we move this, okay, so that is how we are going to show the function for the sine. And let us try moving. Okay. So we moved the line. So from the value of x is equals to 1, we moved it down to the fourth quadrant. This time you would notice there is a change in the value for the x. So the x here becomes square root of 3 over 2. And the value for y is a negative 1/2. So again, this is in the fourth quadrant. Positive value for x, negative value for y. And that our angle here is a negative 30 degree. So the cosine of the angle is simply equals to square root of 3 over 2. In the same way that if you moved again the line, this would become now, the angle is 45 degrees, and that the value for x and the y, again, it is in the same quadrant still. So you have a positive and a negative value, positive for x, negative for y. But you would notice that as the angle becomes 45 degrees, you would notice that both the x and the y value has the same value. Okay, so while the x value is positive, the y value is negative, but still the value for the x and the y is the same. So you have cosine of the angle is simply equals to square root of 2 over 2. Now, moving it further, you would notice we are now on the negative 60-degree angle. And this would become still on the fourth quadrant. So the value for x now becomes 1/2. Okay. Previously, we have here from the 1 unit value of x, the x now becomes 1/2. And the value for y becomes negative square root of 3 over 2. And that cosine of the angle is simply equals to 1/2. So that is for 60 degrees. Now, what happens if we move it on the 90-degree angle? So you would notice that the angle, the cosine of the angle is simply equals to 0. That is simply because the value for the x will become 0, while the value of y is negative 1. Moving it farther, now we have negative 120 degrees, and you would notice that this becomes located in the third quadrant, wherein you have a negative value for both the x and the y. So you would notice that you have the same value, the same sign, negative 1/2 for x, negative 3 square root of 3 over 2 for y. The same is true if you have 135-degree angle, negative sign for x and the y, and you would notice we have the same value, square root of 2 over 2 for x and y. Now, moving it with negative 150 degrees, then you would have the still on the third quadrant, negative sign for x and y. But the x becomes square root of 3 over 2, negative, has a negative sign, and y is negative 1/2 for the value. Okay. Now, if we move it further, now we have a total of 180 degrees for the angle. And you would notice that the value for the x is a negative 1, but the value for y will be equals to 0, simply because we have a 180-degree angle here. So the value for the cosine is simply negative 1. Now, moving it further, we are now on the second quadrant, negative sign for x, positive sign for y. The same is true if we move it on negative 225 degree from our point of reference, okay, in the second quadrant still. The same is true also if we have a negative 240 degrees still on the second quadrant. But if you have negative 270 degrees, you would notice that the value for x will becomes 0 and the value for y will become 1. Now, moving it further, we have on the first quadrant, negative 300 degrees for the angle. Both x and the y is positive. Okay. And if you would notice for negative 315 degrees with reference to our original point, the value for x and y has the same positive square root of 2 over 2. And also for negative 330 degrees, you have positive square root of 3 over 2 for x and positive 1/2 until you go back again to the original position. So now you have a total of 360 degrees. So you would notice that the total angle revolved around a circle is at 360 degrees angle. So let us try if we have sine. You would notice there is a different. Okay, so you would notice the graph here change once we move from cosine to sine. Okay, so this is the cosine wave, while this one is the sine wave. That is the cosine wave. This one is the sine wave. So the cosine wave falls under these different grids, while for the sine falls under this grid lines. Okay, so you have 725, 40, those are the special angles. But for the cosine, you have other special angles like the 360 degrees. Okay, so for the sine, these are the special angles that we have. And you would notice, okay, let us try removing it, going it from the origin. So you would notice from the origin again, let's try moving it the other way around. Okay. For the sine. So if you would notice here, if you are looking for the sine, trigonometric function is sine. We have moved at the 30-degree angle. So the value for sine angle y over is equals to y over 1, or that simply equals to -1/2. Okay, so there you would go, there are the different values. Okay, still you have now in the negative sign for x and y because we are on the third quadrant. Okay, still on the third quadrant, so both negative and negative. So you would notice, what do you notice here? Okay, so you have the same value, the same sign and the same value if the angle is at -135 degrees. Okay, so still on the third quadrant. And again, if you have 180 degrees, regardless of whether this is a cosine or sine trigonometric function, definitely the value for x will be equals to 0, while the value of, the value for y is equals to 0, and the value for x is a negative value. On the second quadrant, x is negative, y is positive. The same is true for the others. Okay, so negative for x, positive for y. Moving it farther down to 270 degrees. Again, the value this time for x is 0. The value for y is a positive value. And that we have for the first quadrant, x and y are both positive. Okay, so there you are for the sign. Right. So let us try moving using the tangent. Okay, so you would notice this, we have the tangent wave. This is the diagram for the tangent. So we don't have any wave anymore. We have a tangent curve here. If you move this, and we are going to try to, instead of moving in the clockwise direction, we now move in the counterclockwise direction. Let's see what would happen. So you have the positive value, positive for x and y because we are on the first quadrant at 45 degrees. Of course, you would notice you have both x and y has the same value, both positive and positive. Okay. For 60 degrees, we are still on the first quadrant. Okay, so for x and y, if x is 0, y is 1, that is at 90-degree angle or perpendicular angle. Okay, moving it further, we are on the second quadrant where X and Y values have negative and positive respectively sign convention. Okay, so you would notice you have the same sign convention because we are still on the second quadrant. So now we are down on the 180 degrees angle. So again, the value for X is negative, but the value for Y is 0. So that's how the different sign convention will be shown. The diagram will be shown. You would notice that as I move the line, you would also notice movement on the diagram. Okay, so you would notice here, this is on the 270-degree angle. Now we are on the fourth quadrant, 300-degree angle, 315-degree angle, 330-degree angle, 360 degrees. So we completed one revolution and so on, so forth. So you can just move, go and go along with the different angles. Okay, so that's how the sine and cosine and tangent trigonometric functions are simulated relative to a unit of x and a unit value of y. So there you go. I shall see you again next meeting. This is Dr. Ram at your service. We have finished one simulation for trigonometry. See you all again for our next vlog.